Warning: this video is literally about gases that ignite themselves simply by touching the air. Don't try anything you see in this video unless you know what you're doing. Aluminum phosphide and all the gases I'll be showing are toxic, and the acids used to make the gases are fairly corrosive. Gloves, goggles, and ventilation are all mandatory. Quick promo, all the chemicals featured in this video came from this channel's official sponsor, Backyard Science 2000. If you ever need hard-to-find reagents like red phosphorus or sodium borohydride, be sure to check out his eBay store, which I've linked below. Alright, let's talk pyrophoric gases. For the uninitiated, a pyrophoric substance is one which ignites spontaneously in the presence of air. Some solid examples include white phosphorus, certain alkali metals like cesium, and ultra-fine metal powders. And for pyrophoric liquids, most are organometallic compounds like diethyl zinc, tert-butyllithium, and alkyl aluminum reagents. Hopefully, I'll be able to do videos on at least a few of these soon, but for now, I'll be focusing on the big three of self-igniting gases: silane, phosphine, and diborane. And brief spoiler, things get scaled up pretty dangerously with some of the later contenders. Okay, starting off on the less toxic end, we have silane. Silane, or silicon hydride, is basically the silicon version of methane, and is probably the most common pyrophoric gas that amateurs deal with, simply because of how ridiculously easy it is to make. Its precursor, magnesium silicide, is literally made by torching magnesium powder with silicon dioxide, otherwise known as sand. In my case, I just scoop some dirt from my backyard and use that, after torching out the water and organic matter, of course. You can see the reaction isn't too violent, although, as Explosions&Fire pointed out in his own pyrophoric gas special, this isn't always the case. But anyway, once things cool down, all we have to do to get our silane is add a bit of hydrochloric acid. As you can see, it ignites with a nice pop and we get this beautiful whitish fireball. Honestly, this is probably one of the coolest flames I've ever seen, and it lets off a decent amount of white smoke, which is just the silicon dioxide from the dirt reforming as the silane burns. Alright, next up we have phosphine. Similar to how silane is the silicon equivalent to methane, phosphine is basically the phosphorus equivalent to ammonia. This gas is honestly pretty terrifying on a number of levels. Not only is it pyrophoric, but it's also remarkably toxic. It burns to form corrosive phosphoric acid vapors, and thanks to its coexistence with other phosphorus hydrides, it tends to stink like garlic. So of course, the obvious question comes up. How do we make it? Well, all you need to do is add a metal phosphide to an acid. The metal phosphide I chose was aluminum phosphide, mostly because I had the aluminum powder on hand, along with a small amount of red phosphorus. In a process similar to the previous one, I simply loaded the reagents into a test tube and blasted them with my blowtorch until they reacted. This caused a somewhat more vigorous reaction to occur, and unfortunately, some of the phosphorus boiled off without reacting, producing a rather stunning tower of fire. Once things cooled off, I emptied out the product to examine it. Every once in a while, you can see a brief fire ignite in the crucible, and my best guess is this is unreacted phosphorus, which transitioned to its pyrophoric white allotrope under the high temperatures. Pretty neat. Anyways, once everything is ready, we can finally make our phosphine Breaking Bad style by dumping the phosphide all at once into a bath of hydrochloric acid. Alright, that was pretty satisfying. So let's do it again. Science is all about repeatability, right? This time, I move the camera back a little so you can get a better view of the fireball. Awesome. Just awesome. Okay, we've now come to our last contender, diborane. This gas is toxic like phosphine, and it has a weird, sweetish odor, but its extreme reactivity towards air tends to prevent these properties from manifesting themselves significantly. You'll see what I mean soon enough. There are a number of ways to make diborane, but one of the easiest ways is to react an acid with sodium borohydride. Diborane reacts with water to form boric acid though, so it's really best to use something like concentrated sulfuric acid when doing this reaction. Of course, there are a few issues with preparing diborane in this way, which became evident in my first small-scale test. The diborane ignited with a loud bang, and the heat of the reaction, not even the diborane burning, was enough to crack my vial and fuse some of the formed sodium sulfate to the glass. This, of course, prompted a second trial, which ended similarly. So clearly, this is a very dangerous reaction that destroys whatever it is put in, and releases an explosive cloud of noxious gas. Clearly, this should by no means be scaled. I scaled it up by roughly 10 times and used a whole lot more acid. This is unsafe, unwise, and come on, what'd you think I was gonna do? Yeah, that was pretty cool. Was it a bad idea? Yes. Did it total my flask? Yes. Will there be more mayhem to come? Of course. So if you enjoyed this video, consider subscribing to my channel. I have a ton of crazy videos planned out that you do not want to miss. And if you want to help support me and my work, consider donating or becoming my patron on Patreon. The links, as always, are down below. A special thanks goes out to all the dedicated LabCoatz supporters. I know I say this at the end of every episode, but this channel truly wouldn't be where it is today without them. Stay safe, everyone, and I'll catch you next time. LabCoatz out.